Okay, let's go ahead and get started. So last time I asked y'all to take a look at the review and see if there's anything giving y'all trouble. Maybe something you wanted extra help with or another explanation, something like that. So, is there anything that you'd like to go over before we go over the review as a whole? Nothing?
Not off the top of my head, but we'll probably go through it.
Okay. Let's just go ahead and get started then. So I've got a version of the review here that I've kind of just changed the numbers around on. So it's the same questions, just different values. Okay? So number one says determine the statement that describes a population, determine whether the statement describes a population or a sample. So it says the high school GPAs of all employees at a textbook company. So is that a population or a sample? Population, absolutely. And what's the key word there? All, yeah. So if we're talking about all of the members of the group, it is a population. If we were just talking about a portion of the group, then we'd be talking about a sample. Very good. Number two, in a blank experiment, neither the subject nor those conducting the experiment know whether the subject is in the control group or the treatment group. So is this a single blind experiment or a double blind experiment? What? Double blind, absolutely. In a double blind experiment, the researchers and the subject have no idea whether the subject is in the control group or the treatment group. Now, what would be a single blind? Yeah. Perfect, yeah, exactly. The researcher or those conducting the experiment, they know who what group the subject is in. So that would be a single blind. Very good. 3. Determine whether an observational or experimental study is appropriate to address the following statement. So a general manager of a restaurant wants to find out her average daily receipts. So is that an observational or an experimental study? Observational, yeah, very good. She doesn't need to change anything about how the data is being collected. She doesn't need to change things that would affect how the data comes out. All she needs to do is collect those receipts and get the data from them. So that's just observational. Good. Next, a physics instructor wants to determine if taking a calculus course before taking his physics course improves students' grades in the physics course. The average class grade would be considered the what? Explanatory variable or response variable? Any ideas? Response variable, good. An explanatory variable is a variable that could explain the driving force behind the phenomena. A response variable is literally a response to the thing that's being observed. So the average class grade is a response to the whether they have taken that calculus course or not. So the explanatory variable would be taking the calculus course affects the grade. But just knowing the average class grade of students who take the calculus course before and those who don't take the calculus course before, that's just a response to have they taken it. Good. Any questions? All right. Next one. mid-sized mobile carrier keeps records of complaints received from its customers. Complaints for the last month are listed in the following table. What percent of the complaints are due to the category incorrect billing? Round your answer to the nearest 2 decimal places if necessary. Okay. So we've got this frequency table here, and we've got a variety of different types of complaints, but what we want to know is, of this category, what does this represent as a percent? So of the total, all complaints. Okay? So this has to be a certain amount, 89 in this case, out of the total amount. It's a part out of the whole. So we have 89 complaints out of the whole. So we need to total all these numbers up. So we have 118 plus 99 plus 87 plus 92 plus 106 plus 89 plus 43 plus 156. And that gives us 790. So this is the part that we're looking for out of the total. Now remember, we're looking for a percent, so we need to equate this to a percent, which is, again, a part, or a percent, out of the whole, or 100. So, what we do now is we say, all right, multiply the numbers that are across from each other, that gives us 8,900, and divide that by the number that's left over, 790, and that should give us our percent. So 8,900 divided by 790 is 11.27 if we round that. Now, as was pointed out in another class before this one, there's actually another way that you can do this, way you can think about it, and that is 89 out of 790. We can make that into a decimal. So 89, you can't really see that, can you? 89 divided by 790 gives us a decimal. All we'd have to do from there is convert this decimal to a percent, which means move the decimal twice to the right. So we get 11.27 still. Does that make sense? Do we have any questions? Okay. Next, consider the following data. Gives us a set of data and wants us to determine the mean, median, and mode. Okay, so if we want to do those 3 things, what is the first thing that we should probably do with our data? Put in order. Perfect. So we're going to put this in order: negative 14, negative 3, 0, 3, 12, and 14. Okay, so first we want to find the mean. So we need to add all these up. So what do we get when we add all these up? What do we get when we sum these numbers? So if you think about it, we have negative 14 and 14. That'll make 0. Negative 3 and 3, that'll make 0. We have another 0 there. Yeah, so the only number that matters here is 12. So then we have 12 divided by how many data points do we have? So what's our mean? 2, yeah. All right, now we need our median. So that's our middle number. So what do we have in the middle of this data here? 0 and 3, good. So we need to find the number that is directly in between 0 and 3. What would that be? 1.5, yeah. 1.5. So we take the 2 middle numbers, 0 and 3 in this case, add them, divide by 2. So 0 plus 3 is 3 divided by 2, we get 1.5. Perfect. Next is the mode. So, do we have any numbers that represent a mode here? No. In order for us to have a mode, we need a number that occurs more than once, and it needs to occur more than all of the other numbers. So, all these numbers occur exactly once, so there's no mode. No mode. All right, any questions? Okay. Next, calculate the GPA of a student with the following grades. So they have an A in a 17-hour course, a B in an 11-hour course, C in another 11-hour course. Excuse me, I got the hiccups all of a sudden. Okay. And it gives out the grades for each of those letter grades. So an A is a 4.0, B is a 3.0, C is a 2.0, D is a 1.0, and F is a 0. And it wants us to round our answer to 2 decimal places. So what's the first thing that we need to do here? Do what? Okay, yeah, that's a good idea. So what do we need to have in our chart? Okay. So I'll make a horizontal chart like this. We have hours and grade. Okay, so we've got 17 hours, 11 hours, another 11 hours. Okay, now we need to fill in our grades here. So we have an A, but what do we want to put in here for our grade? 4.0, yeah. We want to put in the actual value of that grade. So what would go here? I mean, I guess it doesn't matter whether we put the B or the C because they're both 11 hours, but what would the B come out to be? 3.0, yeah. And then this one? No, you're right. 2.0, because it's a C. Okay. So we've got our hours and our grades. So now what do we do? Not quite add, not yet. Remember, this is a weighted mean. So we need to multiply our weights by our values. So 17 times 4, 11 times 3, 11 times 2. Okay, so 17 times 4 is going to give us 68. Then 3 times 11 is 33. And 2 times 11 is 22. And yes, we will add these together. However, there's something else we need to divide this by. What are we going to divide it by? So what are we adding on the bottom? The hours, yeah, the total possible hours. So 17 plus 11 plus 11. Okay. So now we can add all these up. So 68 plus 33 plus 22 is 123. And then 17 plus 11 plus 11 is that right? 17 plus 11 plus... Yeah, 39, okay. Okay. And now we can divide. So 123 divided by 39 gives us 3.15. So there's our GPA. Make sense? So that comes from multiplying our weights by our values. So 17 times 4 is 68, then 11 times 3 is 33, so on. Make sense? Okay. What other questions? Good? All right. Next. For the graph below, determine which letter represents the mean, median, and the mode. Letters may be used more than once. Okay. So the one I always look for first is the mode. And if we're looking at one of these types of graphs with this curve, we are looking at frequency. So the higher that curve goes, the more frequent that value is. So this peak right here is the most frequent value, which means it is the mode. Okay, so there's A. Median is the number that splits our data in two. So that's B. And mean is always on the other side of the median from the mode. So that's C. And that's it. Any questions? All right. 9, consider the following data. And it wants us to calculate sample variance, sample standard deviation, and the value of the range. Now, I believe I took off sample variance in our review. I just kind of left it in here so I could show you today. But I am more concerned with y'all knowing standard deviation than variance, because variance is just a part of standard deviation. So we're talking about a sample here. So our formula for standard deviation of a sample is S equals the square root of the sum of x minus x bar squared over n minus 1. So first of all, what is x bar? What does that mean? Does anybody remember what x bar is? The mean, yes. When we see a variable with a bar over it, that's the mean of that variable. And we only have one variable in this data set, that's x. So we just have the mean of x. Remember yesterday, or not yesterday, but Monday, we were talking about x bar and y bar when we were doing the correlation coefficient and things like that. So when we see a hat, or not a hat, a bar over a variable, that just means mean. What is n? Yeah. How many data points we have? That's n. Okay, so we need to know the mean and the n. So first, let's find x bar. So we're going to add all these numbers up. So let's see, -6 plus 4 plus -9 plus -4 plus -4 plus 9. We get 36, or -36, and then divide by 6, so we get an x bar of -6. All right, how about our n? What is our n? 6. Okay. So first, the variance. Variance is just this without the square root. So if we calculate everything underneath that square root, we'll get the variance, and then take the square root of that number and we get the standard deviation. That's why I'm not that concerned with variance, but we'll do it today. Okay. So we need to find our x minus x bar, which means we take each of these x values and subtract the x bar value, or the mean. So like this first one here, -6. Again, we subtract the x bar value, And when we plug in a value for a variable, we use parentheses. So we have -6 minus -6. Now what's going to happen here with this double negative? Yeah, turn positive. So this really is -6 plus 6, and what does that give us? 0. So that's how you need to calculate these things, okay? Make sure that you have the correct sign. So next we have -4. So -4 plus 6 is 2. -9 plus 6 is -3. Again, -4 will give us 2, 2, and 3, -3. Okay? So now, we've got our x minus x bar. Now we need to square it. So we're going to square each of these values. So 0 squared is 0, 2 squared is 4, 3 squared is 9, 2 squared is 4, and 9. Okay, so we've got all of those. So we've done x minus x bar, we've squared it, now we need to get the sum. So we're going to take all these numbers and add them. So 0 plus 4 plus 9 plus 4 plus 4 plus 9 is 30. And now we need to divide by n minus 1. So our n is 6, n minus 1 would be 5. So divide, and we get 6. Whoops. Okay, again, that's our variance. So just calculating the stuff underneath that square root is the variance. Taking the square root of that then gives us the standard deviation. So now I can just hit square root on my calculator, and it gives me a standard deviation of 2.4. Okay, and last is the range. Now remember that range is a distance. So when we've got these negative numbers here, we need to kind of ignore them and just think about distance. So what's our biggest number? What's our minimum and maximum? -4 and -9, yeah. So what's the distance between 4 and 9? How many spaces? 5, yeah. When you get into algebra, you'll see that what we just did there is called an absolute value. Okay? Basically all it means is just, what's the distance? Ignore positives and negatives, just what's the distance. Okay. Good. Any questions? All right. Y'all are flying through this. Last one. Suppose that a company wishes to predict sales volume based on the amount of advertising expenditures. The sales manager thinks that sales volume and advertising expenditures are modeled by the following linear equation. And it's important to note, both sales volume and advertising expenditures are in thousands of dollars. We need to keep that in mind. Okay. So the model is that estimated sales volume equals 47.58 plus 0.55 times advertising expenditures. So in other words, if they spend a certain amount on advertising, they should expect to get a certain sales volume. And that's what this is saying. So if the company has a target sales volume of $300,000, how much should the sales manager allocate for advertising in the budget? Round your answer to the nearest dollar. So what this is asking is, if we want to make $300,000, how much money do we need to spend on advertising? Okay. Now again, this is in thousands of dollars. Each of these is in thousands of dollars. So this right here, this $300,000 that we're plugging in for sales volume, when we plug it in, we need to plug it in as thousands of dollars. It's 300,000, so it's 300 that we plug into here. Does that make sense? Again, that's because this is supposed to be in thousands of dollars, so we have $300,000. So plug that 300 in, and then we've got 47.58 plus 0.55 times advertising expenditures, which I'm just going to call A. All right. So now we need to solve for A. We need to get A by itself. So what's the first thing that we should probably do? Perfect, yeah. That's the easiest part to get rid of on this side. Of course, we could divide by 0.55, but we'd have to divide this by 0.55 as well. I don't really want to do that. So we subtract that. We have to do it to this side as well. So it'll cancel there. And let's see what we get. 300 minus 47.58. And we get 252.42. Okay. So what's the next thing that we can do? Perfect. We can divide by 0.55 since it's multiplying by A right now. And that will cancel it. We need to do it to this side as well to keep balance on this equation. Okay, so it's canceled there. We just need to divide by 0.55 on the other side, and we get, let's see, 458.945454544, so on and so forth. It repeats. Now remember, this is supposed to be in thousands of dollars. So we need to convert this back into thousands, so we need to move this decimal place a little bit. So if we want to convert this back to thousands, we move this decimal 3 times to the right, and we get 458,945, and it's already rounded to the nearest dollar. Which is bad news for this company, because that means they're going to be spending more on advertising than they're going to be getting out in the sales volume. They're spending almost $500,000 and getting $300,000 back, so they've got a loss of about $200,000. Looks like they need to get a new sales manager. All right, any questions on that one? No? Makes sense? Any questions on any of them? Okay. So again, this review is due the same day as the test. When is that test?
Friday.
Friday. So, I would like if y'all could turn these in before you take the test on Friday, but that's not necessary. You can wait all the way until midnight on Friday to turn it in. Okay? The reason I want you to turn it in before test time is because that tells me that you've done the whole thing before you're taking the test. And if you do this whole thing before you take the test, you should be pretty prepared. Okay? So again, you don't have to turn it in before you take the test, but I'd appreciate it. All right. But I think that will do it for today then. So, use the rest of this time that I'm giving you outside of class to prepare for this test. I want you to study, study, study hard for it. Let's all make hundreds. And I'll see y'all on Friday. What's up?
Do you know when you're gonna move the class to online?
Excuse me?
To Zoom?
I didn't quite hear your question.
When are you gonna move our class onto Zoom?
So, we've already got the Zoom class set up for the people who are distance learning on this one. But, from what I understand at the university, all classes will move to Zoom after Thanksgiving break.
Okay.
Unless there's something else that happens and we have to move earlier.
Oh. Cause
But-
I heard we can leave back home, already move out in November, it's never, our class is already on Zoom.
Huh, where'd you hear that?
An RA.
Okay, I'll have to do some research then, cause I haven't heard that yet,
Okay.
but I'll get back to you on it.
What is it?
They